Okay, everybody. Good afternoon. This is the 2020 final closing ceremonies and the presentations for the Space Apps Challenge. I want to thank our local sponsor, AWS, and also they're a global collaborator for the international event. And so what we're going to do now is I want to quickly introduce, here's the team order, but let me quickly introduce our three judges. So Robert Kahn is our first judge, Director of Software Engineering for Space Operations at Black Sky. And lots of experience. He's been at Boeing and done some work at Microsoft as well. So welcome, Robert.
Thank you.
Next is Vladimir Baranov. Vladimir is the CTO and co-founder of Advisor Engine and has done a lot of work at other startups as well. Has a computer engineering degree and an MBA at the London Business School. Welcome, Vladimir. And then finally, Jeff Rayner. Jeff runs MXT Reality, Mixed Reality. It's a local VR company. And I've known Jeff a couple years actually, great guy. So his team, they work with VR, AR, drones, 360 cameras, even things like smells and tactile for their VR apps. Very cool stuff. They have a lot of apps up in the Steam store, so go check them out. Welcome, Jeff. Okay, so team order. We're going to go by the challenges in the order they're listed on the main website for Space Apps. So Observe is the first challenge. And then within those 6 challenges, we'll go alphabetical order. So the first team today is Big Sky. Every team will have exactly 4 minutes. I will keep count. I will keep a timer here. And I'll tell you when you have 1 minute left. I'll just say 1 minute. Okay, so does anyone have any questions before we start? Okay. Big Sky, are you guys ready?
Sure.
Okay.
Can you hear me?
Yeah, I can hear you. You're really low though. If you can boost your microphone, that'd be great.
Yeah, let me just switch my microphone for a sec.
Oh, that's much better. Let me know when you're ready to start. You can go ahead and share your screen. And I'll go ahead and turn my video off.
Okay, so is this like a bit better?
Yes, you're good.
Okay.
Go ahead and start the timer.
Yeah, so we have actually not finished it yet, but wait, for some reason my share screen isn't working. Okay, maybe just do that. Okay, so here, this is what we have so far, and it's not really finished yet, but yeah, so basically we have this sky sphere thing, and then we have listed a few of them, and then when you click on like one of them, let's see here, and then it's going to show up like data observed, and then which like system is this, and then it's going to show a download image button that downloads the TIFF file. And right now this thing is like not really set up correctly yet for some reason. And then here we have a search for Kearsarge in case you want to have like really accurate like specific galaxies, and then you can enter coordinate, the size, and then keyword and waveband, and then it's going to show up. So yeah, this doesn't quite work yet. We have all the functions in the background, but the HTML file isn't quite finished yet. And then we have a list of all objects that's going to be like a list of things here. So these ones are all from the wait, where is it? Neosat data center data files. And then if you click on like one of them, it's going to show up as a TIFF download, which is what it's supposed to be doing over here. But this one is kind of broken on a minute. It's just going to show 404, but you can just download this and then you can just save that. And do I have to show a code? Like, wait, where's soon? So do we have to like show our code?
No, you don't have to show your code.
Okay. So yeah, that's what we got so far. And then we have just a little bit like of tweaks that we can do to make it like work properly. But yeah, that's what we got so far.
Okay. Judges, do you have any questions?
I have one. This is Vladimir, and I apologize if there was some conversation before that. I was on mute and I couldn't hear anything. Question for Tom. What impact are you trying to drive with this project? Where do you think it's the most applicable?
So for data researchers,
Sorry, you're a little bit too far. Would you mind coming close to the microphone?
yeah, my microphone's kind of weird. But yeah, so basically you have as, what do you call these? Like just space researchers, right? And then you have space engineers that are like studying galaxies, and then they can access the data files quickly with this, and they can search up things and then look up like exactly where they are on the sky map and the location, like yeah.
Okay, thank you. I don't have any more questions.
Okay.
A quick question.
Go ahead, please.
So you said that you're not quite ready to show it. Do you have an idea of when you think you guys will be complete?
By tonight.
Yeah, just a reminder, everyone has until 1 minute before midnight tonight to submit their final their final solution essentially to the Space Apps website, and we'll talk about that at the end of this call. Okay,
Awesome.
our next team is Orbit, also going after the Observe challenge. Orbit, are you guys ready? Team Orbit, are you guys here at the meeting? Orbit going once, Orbit going twice. Okay, we will come back to you at the end. Tactile terrain, you guys are up. Are you ready to present?
Yep, we're ready to rock.
Okay, you have 4 minutes.
Okay. All right, can you guys see our screen?
Yes.
Hi, so we're Team Tactile Terrain. Our mission statement was bring data into the real world in order to understand it personally through a tactile experience. So a problem that we saw, real-time map data does not feel real to the average person, and it's typically difficult to navigate and to digest. And so we saw that as something that we could really key in on. And so our solution was a real-time topographical display that harnesses the NASA data for specific filters, whether it's fire, ozone layer, cloud cover, traffic, or the like. So value add would be be able to personally interact with the data. So it allows you to tactilely touch and see and feel what's going on around you. It's a live display, so it's pumping in live data all the time. So it gives you up-to-date responses. So whether you're at an REI about to go for a hike, you can see where something might be happening or whether it's a good time to go outside because of the air quality is bad. And it makes your window into the world much bigger. So it allows you to get out of the, something that you might not pick up as personally from a web application, and allows you to get down into it and see it and feel it. So jumping into prototype that we created, this is what we would like to see from a visual experience. We want you to be able to download that same prototype to be able to physically see it, both the code and a CAD file that you could print out, 3D print. It has a shareability feature where you could share it and get the message out for everything that's going on with climate change. You're able to set any notifications or anything like that. And then, so here's a real-time display of what we would like it to look like. So let's say fires are happening, right? So we can zoom out, see what's going on around us. We can go in, see what's going on with air quality in the same way. And we'd like to see that for many other potential options. So, oops. Come on. Oh, sorry about that. Then, so we have a live site up and running, which is showing our cloud cover, which is streaming in live data from the NASA API. And then lastly, here's our actual hardware prototype of live data being streamed in to the LED display, which we see as a great opportunity to be plugged into your local REI or
1 minute.
future to be able to bring the experience of NASA's data and data from climate control and anything into the classroom and or your everyday experience to really bring that in and make it personal to the everyday user. Thank you.
Okay, judges, do you have any questions?
Yes, great presentation. Question about this terrain prototype. Did you make it during this weekend or did you bring it in from outside?
So the actual UI prototype, the website I made this weekend, and
Sorry, hardware.
yeah,
the slide you're on right now.
Yeah, so we're actually a team of members at Seattle Makers here locally, and so we had a physical display, and we went ahead and had one of our team members go ahead and print out the actual topographical map, and our other teammates were able to actually code up the live feed that is plugged in that you can kind of see in the background here from the which is live streaming temperature in the area. And so that's all happening. This is all stuff that happened this weekend. So all the code, all the printing, the laser cutting, everything for the hardware was done this weekend.
And quick question. So how would you solve a technical question of LED not able to shine through the thick part of the mountain?
Yeah, so that's a good question. Something that we actually were throwing around this weekend, where we'd like to figure out a way to either make it more transparent and or almost have, if there's a possibility of having actuated LEDs to show an even brighter display, that'd be great as well.
All right, thank you.
Okay, guys, we need to move on to the next team. So next team is going after the Inform Challenge, and that will be Cattle Footprint. Cattle Footprint, are you guys ready?
Yes,
We're
we are.
ready.
Awesome, you guys have 4 minutes.
Great.
Alright.
Just share. Okay. Can you guys see the screen?
Yes.
Okay. I think. Go ahead, Rankusha. I think in our
Okay.
team.
Yeah,
Oh.
so welcome to Seattle Footprint. Seattle Footprint, who passed the gas? This is an interactive visual tool to track greenhouse gas emissions and to visualize a carbon footprint. We have your reader right now, Ron, Shahir, Mohit, and Elaine on the team.
We are looking at the world's carbon footprint. climate change is influencing people's lives everywhere. Combining public information is crucial to making Earth policy decisions vital to our health, our economy, and our future.
So what is the solution? The solution is an interactive web application that tracks and visualizes the greenhouse gas emissions. We take land use data and couple that with greenhouse gas emission data and also fire data that informs policymakers on decisions relating to fund allocation and land development. Like I said, our parameters are human settlement, which is population density, global power plant structures, fires, topography, and land cover. We kind of try to get all that in there together.
All right, so how it works? Well, all of this is based on Google Earth Engine's cloud platform. That is one of the very powerful platforms for doing any geospatial analysis. And so we developed a standalone web application based on Google Earth Engine. It pulls the data from NASA, ESA, and other agencies, and then all in real time, and then performs the analysis right there. And we have JavaScript API that we use for that. And so it's all a real-time application that anybody can pull, and we don't need any Google account or anything for that. So here is the publicly shareable app, but I will just show a quick demo from my screen for now. Let me just quickly go there. Can you guys see the screen, or are you still seeing the
Yes.
Okay, can you see the video?
Can see the blue and green.
Oh, okay, one second. Let me just share the.
1 minute.
I can see calendar.
Can you see the video now?
Calendar. I think we saw the video on the previous one. Blue and green like fog. I don't know if that's what you intended to present.
Okay, can you guys see now?
Yes. I mean, it's the same blue green video.
Okay, awesome. So this is the quick demo of our app that we just built. So here is the it's all online web application. We have multiple data sets that we are using. So we have one of them is the power plant data set. As you can see, we have biomass and other kind of power plants that we are using. Then we have population density here that anybody can just switch on and off from there. We have elevation and we have land cover use, right? So these are the base maps that anybody can analyze, any policymaker or all. And then as soon as we click on one of the points on the map, it shows a option to select any greenhouse gas, right? So I suppose I select
Your
NO2.
time is now up.
Okay, so, and then we have a time series and then we have fire data set as well that anybody can go and analyze, and it's all global. All right, so so just to conclude for that, sorry about that.
Judges, do you have any questions for the team?
Jeff, go ahead, because I took up the last time. All right, then I can step in. Do you think, how can you improve the interface to make it, let's say, less busy? Or maybe perhaps you made a consideration to make it more busy to provide more information. What was your thought pattern behind that?
I can answer this
Actually,
question.
so
Yeah, go ahead.
Okay. Yeah, so we did not intend it to be make it more busy, but it's just like it's a sequential process. So a user at the very first, he just sees the map, and then he clicks on the map, and then right here, for example, and then it shows this particular time series chart, and then he clicks, he can select multiple drop-down menus, multiple options of greenhouse gases from this drop-down menu. So it's like a sequential process of displaying the information. We tried it, so in that case, we tried it to be much more simpler. And then this is just a legend, and for example, how much CO emission is there. So this is like added information. But because
we need to move on to the next team, guys.
Okay, sure.
Okay, thank you very much.
Yeah.
Next team is Fired Up. Fired Up, are you guys ready to present? fired up? Are you guys ready to present? Okay, going once, going twice, fired up. We'll come back to you at the end. Next team is Husky CO2.
Yep, we're ready.
Awesome, you have 4 minutes.
Okay, let me just share my screen here. Hi, we're Husky CO2, and this is our project, Elevating Emissions. So who we are, we're all CSS students, computer science and systems students at the University of Washington, Tacoma. We're a group that are looking to inform others on the effects of carbon emissions using our computer science skills that we've all learned so far. And we're also students that like to challenge ourselves by going to hackathons and doing online programming competitions. So just to reiterate our problem, what is our carbon footprint? Our challenge was to identify local sources of carbon emissions and or estimate amounts of carbon emissions for different human activities to aid scientists in mapping carbon sources and sinks. And then the other part was obviously to build something to inform. So part of the importance of this is global warming affects everyone. That's why it's called global warming. It's the whole Earth. So some of these side effects are Earth becomes warmer, the glaciers and ice sheets are melting, climate change can head to crop losses and threaten food security. This can also affect your personal health. It can give you things like headaches, dizziness, and difficult breathing due to the carbon emission exposure. And it also increases the ocean acidity. So personally, we are the next generation since we're all young students, and we are part of the generation that will live with the permanent damage if this continues. So our project, we decided to create a web application based on just to educate and inform, and we provided visual aids of the data that we use from NASA. And so part of it was we listed the polluters. We created and researched potential solutions based on those polluters. So now we'll show just a little demonstration of our website. Can everyone see it?
Yes.
Yes.
Okay, so here's the front page. So we have our, just a pie chart showing the distribution of the economic sectors that contribute to the emissions. And then I'll show you an example. Here we have some of the potential polluters, and here we provide some solutions. These are large-scale solutions, so not something that everyone can do. And we even provide local solutions. This is more for the average person that they can accomplish. So if we click on one of these links here, it'll take us to either an article or some research showing what they could do and how it would help the environment. So some of the next steps that we wanted to do was predict future emission for each sector according to the data we have now. And each sector when people change their actions. We also want to update with new data and update the graphs. And we also wanted to find data for each state and city individually and add more emission sectors and more solutions. Thank you, and that's the end of the presentation.
Okay, awesome. You had 1 minute remaining. So judges, do you have any questions?
I do a quick one. First of all, thanks to everyone. I realize these are super hard and fast as we go through them, but we will follow back up later with questions if that's okay with the committee there.
Absolutely.
Question for you quickly there. You had some of those icons and the text hyperlinks to give additional info there. Are you thinking in the ideal world they would also be filters that would have changed the charts to the sides as well? Or was it just to give info about, you know, where you got the pie chart and then you went through to a page and it had all of the different factors that were causing global warming, for example, CO2 there?
Yes.
Would those, are you imagining the filter, the columns to the left, are they expected to be, if you had more time, or is it even possible that they are filters to be able to tell you the difference between the shipping versus the airplanes versus the cattle, etc.?
Yeah, we were just thinking more of a general of the polluters and the problems. So you want to?
And we, just to double check, James and Mike, do we get to actually play around with some of these too later during the week? Is that right?
Mike, do you want to take that one?
Yes, absolutely. We
Awesome.
have a period between today and when we will convene for judging, where judges will be able to take a deeper look at the projects. If they have online resources available, definitely you want your project page all set up by the end of the day to be eligible for global judging.
And we'll go over those instructions at the end of this call for everyone to submit their project for global judging. It's due tonight at 1 minute before midnight. Local judging is next week, and we'll be meeting on Thursday, but we don't need to turn in the finals until the 12th, which is Monday, next Monday. Okay, next.
To clarify things, it's midnight, what time zone?
It's our time zone, right, Mike?
Correct. Midnight local Seattle Pacific time. Yep.
It's actually 1 minute before it's 11:59, but yeah, our time zone. Okay, next team is going after this Sustain Challenge. Team is Agribusiness AI. Are you guys ready to present? Team Agribusiness AI, you guys are up. Is anyone on the call? Okay, last chance, Team Agribusiness AI. Okay, well, then we'll move on. The next team is going after the Create Challenge, and that team is Binary Search. Binary Search, are you guys ready to present? Binary Search, are you guys on the call? Okay, we'll move on. Chico Movers is the next team going after the Create Challenge. Chico Movers, Chico Movers.
Hey there. Yes, we are ready to present.
Okay, awesome. You have 4 minutes.
All right. Let me get myself situated here. Great. So just give me a moment to share my screen. Alrighty, can you all see my screen there?
Yes.
Yes.
Great. So thanks for having us on this hackathon. It's been a very fun and engaging experience. The longest any human has lived on record was 122.5 years old. With current technology, it would take humans over 75,000 years to reach our nearest star, Proxima Centauri. That means none of us will get to explore the stars, even on a screen, much less in person, unless we start making radical advancements in research and development of new propulsion technologies. So here's the team. We have Matt, myself, Ben, Raham, Henry, and Ajin. The problem we face is that advancements in our technology are relatively slow due to the unique skill sets and interests of rocket propulsion scientists and researchers. Without a significant development in propulsion technology, exploration will be severely limited. One hindrance is the lack of understanding of today's propulsion technologies or the exciting new possibilities of the future for upcoming generations. The team decided to create a program that showcases existing, new, and theoretical methods of propulsion to help raise awareness about the importance of investing in this new space propulsion techniques. In addition, our goals include teaching about different methods of propulsion, informational factors related to each propulsion type, such as fuel characteristics, thrust, pros and cons. In addition, distance and time measures between celestial objects in our solar system. With that, let's move over to our demo.
Sorry, we cannot see it.
Oh, oops. Sorry, let me share that again.
Can see it now. Good.
Great. So of course, there's several assumptions that we took into account. Um,
One minute.
Sorry, I'm a little bit going back and forth here. Okay, back on track. So some of our future implementation plans include reaching out with NASA Kids Club and other organizations to get kids inspired. We would also expand additional destinations, propulsion techniques, interstellar expansion, and scenario-based missions. So here's a listing of some of the references we used in our research. And with that, I want to say thank you and let us know if you have any questions.
Yep, you guys, good job. Judges, do you have any questions?
Quick question from me. Who is the audience that is your target audience for this tool?
So our target audience is really to inspire kids. So it would be youth, anywhere from, I guess, ages 3 probably to, teens.
Thank you.
Any other questions?
No, I like it. I want to play with it and dig into it some more. Looks fun. Nice job.
Awesome. Thank you.
Thank you so much. Okay, our next team is Trappist 1. Trappist 1, are you guys ready to present? Trappist 1, last chance. Are you ready to present? We'll move you to the end. Are you there, Trappist 1?
I'll put a message in the Slack.
Okay. Okay. Next team is the first of the teams going after the Confront challenge. This team is Blaze. Blaze, are you ready to present?
Yep, we're good to go.
Yes.
Awesome. You have 4 minutes.
Welcome to Team Blaze, a group of 9th graders working on the Space Apps Challenge of Spot That Fire version 3.0. Made by Andre Yee, Divij Ashwin Kumar, Pranavi Rohit, and Varsha Balaji.
Our goal with this project was to define the relationship between wildfires and economic change and the effect they have on communities. And our main design strategy was to analyze wildfire and economic data to draw trends. Our purpose was to gain valuable analytics and visualizations to be able to predict wildfires and see how they affect the economy. Our strategy was to first collect the data, or research the data and collect which ones we need. Then we put it through a set of processes to thin out the data, then we put it into a machine learning model to get our analysis.
Next slide.
We used an extensive data collection and processing pipeline. We found satellite data for fires from the NASA Firms Archive and economic data from the Federal Reserve Economic Data. We applied a variety of standard data cleaning tasks. Because NASA Firms data contained a lot of arbitrary information, second-by-second information for every latitude and longitude, we performed a random sampling to reduce the data set to make sure it was more computationally feasible. We wrote a script to merge the 2 timelines of the data. One was on a second-by-second basis, and another was on a weekly basis. And finally, after we pre-processed the data, we put it into several machine learning algorithms and optimized the best ones by fine-tuning hyperparameters. Out of the several tested algorithms, we used the winning model to perform two tasks. Firstly, to predict the fire radiated power, or FRP, a measure of a wildfire, and to predict the economic index. The former task allows us to predict instances and severity of the fires, and the latter allows us to see its impact on the economic indicator. Our goal was not to perfectly model the economic index, that would be impossible given only wildfire data, but to perform analysis to find the significant impact it might have. In order to perform analysis, we used a variety of algorithm explainability metrics to find which factors influenced the model to make certain decisions. In the following slides, you'll see some of the important visuals and analytics we were able to derive from this model.
Our first part of our analysis was to find factors that most influence the FRP, or fire radiative power, which is the radiant energy released by burning vegetation per time unit. The two factors were brightness and scan. Brightness helps gauge how destructive a fire is, and scan helps gauge the size. So they can both contribute to finding out how much burned vegetation there is.
1 minute.
Three factors which impacted our measure of economy the most were longitude, latitude, and brightness. Longitude and latitude are relatively straightforward. This defines the location of areas affected. Brightness likely had a great impact in both economic change and wildfires, as it indicated the intensity of the fire. The greater the intensity, we can conclude that the fire was more powerful and more widespread.
Some of the significant results we found showed that bright T31, which is the brightness measured in Kelvin from the 31st channel of the MODIS satellite, was an important factor in both economic state and wildfire prediction, meaning its value can be a good indication on the effects of both. As we can see in all three diagrams, the correlations between confidence, brightness, and bright T31 almost guarantee fires in some cases, and also showed economic losses, as we can see on the right side of the y-axis within the figures B and C. In figures A, we can also see that
you guys are out of time. Sorry. Judges, do you have any questions?
Yes, I have a question. If, let's say, I was a governor of a particular state, how would I be able to use this tool proactively to address either forestry techniques or my budget? Have you guys thought about that?
For this particular project, we used kind of national data, but we did some small tests, and I think you can find this in our code repositories, in which we could use economic data for more local regions. And I think you could use that to test how how various wildfires of different severities and different sensor data inputs are going to affect the economic indicator for smaller regions.
Any other questions?
Yeah, the geolocation stuff, obviously, if you're next to a major city, the economic impact is going to be that much greater. How do you account for that?
So within our model, the machine learning algorithm was able to understand based on the longitude and latitude where it was on the globe, and based on that also make predictions based on whether there were major cities nearby.
To add into this, our end model is tree-based, so it kind of has in memory, it's able to figure these things out.
Okay, thank you so much, Team Blaze. Good job. Our next team also going after the Confront challenge is the fire spotting team. Fire spotting team, are you guys ready to present?
Not quite yet.
Okay. We can come back to you at the end. Next team will be Luna Tudor.
We are ready to present. Can you hear me?
Yes, I can hear you, Luna Tudor. Go ahead. You have 4 minutes.
All right. This is not going to be very long, but thank you for having us. With remote learning increasing in popularity, our goal was to make a absolutely free, accessible educational platform where anyone can ask or answer science-related questions. We made a simple social media platform called LunaTutor, where all posted questions are accessible. They can be viewed without signing up, but signing up is required to ask questions and contribute. Our target audience is K through 12 students. Accessibility and ease of use are extremely important to us. So we wanted the user flow to be familiar and easy to use, similar to Reddit or Quora, but with a sharp focus on education. Being a simple question answer forum, we wanted no fuss with links or videos. Can you see my screen all right?
Yes.
Okay, so not all features have been implemented yet, but it's pretty simple so far. What you're seeing right here is a general feed board for all the questions posted, with some dummy questions, like our tree screen. I don't think that's really appropriate, but we do have subject boards that users can go to post subject related questions. Asking a question is pretty simple. We have a user form that is just separated by subject. You can just put in a title, put your questions, and we are implementing a hashtag feature. So you can see related questions that are where the specificity is, well, if it's more specific than just like tying to the subject. Clicking the question will bring you to the answer board where any user can contribute answers. If there are no answers, a badge comes up. For answered questions, a list is appended here. Users can upvote based off of if they found the answer helpful. And of course, the most helpful question is appended to the top. That's pretty much it. That's all we have right now.
Okay, no worries. Judges, do you have any questions?
Yeah, I have a question.
Jeff.
Which is, how do you expect the K through 12 students to find this, and what are they actually using it for? What are they trying to solve?
This platform was meant to be just like an ease of use platform. We know that Reddit is useful for answering questions on an educational basis, but I mean, there's just so much functionality with Reddit that we just wanted a primary focus on education.
It's like Quora for kids. Is that fair?
Yes.
And have you used any NASA or federal data sets?
No, we haven't used any of the NASA APIs.
Okay, thank you.
Any other questions? Okay. Okay, thank you.
All right, thank you.
Next set of teams are going after the Connect challenges. So the first team is Exploration. Exploration, are you guys on the call and ready to present?
Yes.
Awesome, you have 4 minutes.
Can you hear?
Yes, I can hear.
We cannot
hear the video though, yeah.
Oh, you can't hear the
Hi, my name's Kevin. I'm a high schooler from.
Hello, my name's Jungmin. I'm a college student from Auburn.
Hey, my name is Divya and I'm a high school student in California with an interest in all things space. We also have 2 other team members who unfortunately could not make it to this presentation due to personal reasons, but their names are Leo and Sumant.
Team is Team Exploration, and this is our first time meeting together and doing this challenge. When we first started this hackathon, we were strangers, but now we're friends working towards a common goal, better space exploration. Astronaut John Young once said, "Single planet species don't survive." Our astronauts risk their lives every day to advance space exploration, making quick communication essential to keeping them and the data they collect safe. However, communication with Mars can take up to 22 minutes, and sometimes even 2 minutes is too long for a dangerous situation. This is why making communication on Mars faster is essential not only to preserve data, but to save the lives of the brave astronauts who go to advance human knowledge of the galaxy we live in. Some concept art of what our plan is. This is how we are going to establish connection to Mars. The first way, single satellite, is basically how NASA is doing it right now. We use 1 satellite, but again, it takes around 20 to 30 minutes for communication, which is not very desirable, although it is not that slow. The method that we're going to be using is the Starlink method, where you deploy a fleet of multiple satellites, which can then transfer data much faster than 1 big satellite. It can reach speeds of up to 100 megabytes per second, which is pretty impressive. we're going to have a satellite relay system where we're going to have a starter fleet, which is going to be positioned close to Earth or Mars. We're sending data from there. And it's going to send some data to the middle satellite, which is a pre-existing satellite in space with Starlink satellites docked into it. And it's going to send that data to our closer fleet, which is going to complete the sending of the data. We're going to dock these satellites in a way so that it can catch the message from the planet we're sending it from and throw the message to the satellite that's going to complete the transfer. The main satellite could also be used as a backup if the Starlink satellite dies, which would only happen under extreme circumstances. But how can we make our ambitious plan easier to understand for the younger generation?
We can do this by making a program, and our program is a game designed to show the different types of communication with Mars and each of their benefits/drawbacks. The user who's playing the game will be given an option to select one of 3 kinds of communication: radio wave, Starlink, or neutrino beam. The radio wave option is more after the current form of communication with Mars. It's proven that it works, but it's not very efficient, like we've said. The second option is based on SpaceX's new system for internet on Earth, which utilizes a vast number of Starlink satellites. In our game, these satellites will be arranged between Mars and Earth instead of just surrounding Earth like they are currently. The third option is purely theoretical and is based on neutrino beams and their potential to transfer information. Each of these games has a unique task, and right now we will demonstrate the radio wave game. Here the user is tasked with angling the satellites so that they face each other. If the task is done successfully, the user will receive 10 points.
In order to further improve our innovation, we will update the game by adding pricing as well as levels. We hope that our game will be able to inspire future generations of scientists to tackle this ongoing problem of quickly communicating with astronauts on Mars. As our next generation is a generation that will go to Mars, we hope that it will teach the younger generations of advantages and disadvantages of choosing time over the cost and vice versa. Perhaps one day the future generation of scientists will be able to work off our project, making communication to Mars faster and cheaper. Thank you for listening to our presentation, and we wish you an amazing rest of your day.
Hi, my name's Kevin.
Thank you guys. That was good. Judges, do you have any questions?
Have you guys thought about the psychological impact on having to wait for a reply for 20 minutes? And have you thought about any process of improving that psychologically or technology-wise?
We wanted to do links. So originally we were going to do a Starlink, which had fleets both by Earth and at Mars, and then have a middle satellite to help do it, help send the information faster, because we wanted to help the astronauts who are in need, because sometimes it'll take too long to actually send the data if it's an emergency. So we wanted to make it faster than that. But then we realized that we don't exactly know how to do that yet, but we knew future generations would be able to do that. So we want to help inspire them instead to actually be able to do that and understand what our problem was.
Okay, thank you.
Any other questions? Okay, thank you very much. Next team up is Team Glass.
Hello.
Hello, are you ready to present?
Hello. Yes.
Okay, you have 4 minutes.
All right, can you guys see the screen?
Yes.
Yeah.
All right, whenever you're ready, Vishnu.
Hi, we're Team Glass, and we created an application called Look Out the Window.
All right, so with like this subtopic of connect, what we were trying to do is bring more awareness to the average person with how much technology there lies just waiting for us in space. And as the technology advances and matures, it's more eye-catching and it's interesting, right? So we thought, how could we switch like the perspective of the average person who looks out their window at the sky with something more powerful, when something that allows them to change how they see the universe around them?
So what we ended up doing is we made a website called Look Out the Window, and it allows people to learn more about satellites. Once you first start out on the website, as you can see in this screenshot, you start on an Earth view, and that basically shows an overview of the globe and all of the satellites orbiting it. So with the Earth view, you can choose a specific location on the globe, so that in the next slide, you'll see that it uses that location for the space view. And you can zoom in and out and then orbit around the globe to find wherever you want to position yourself.
Another option we have is the space view, which is looking up at space from a location on the surface of the Earth. And when you look up at the space, you can see accurate representations of satellites and their positions relative to the viewer who is standing on the surface of Earth. And you can also pan around the camera to look around and see nearby satellites as well as those right on top of you. And you can zoom in and out to get closer looks at satellites.
All right, so we also have a satellite view function, and that allows us to take a random satellite's perspective and what that satellite sees and map it into our application. And so there's also an additional functionality to kind of pan around sideways instead of just looking straight down at the Earth. And so the user can also zoom in and out to just kind of see what that satellite sees up in space.
So looking forward to the future, we realized that we created a pretty cool app, but we know there's much more we can do to make it more immersive and personal. The main avenue we see this in the future is adding it into a VR application, as this will allow for an even more immersive experience, as you'll be legit viewing it as if you're in space. And a last feature we were considering was adding a build a satellite mode. It'll be a very interactive mode where a user will be able to learn more about satellite design and positioning, and will allow for that further deeper connection to satellites.
All right, and that's our presentation. Thank you for listening. And I encourage you all to look out your window.
Thank you. Judges, do you have any questions?
Jeff, if you don't, go ahead.
Sure. Do you track the movement of those satellites around? And
yes.
That are you using from NASA and that to do that?
Yes, we track as you can see on the website, they'll move you can see them moving as they orbit the Earth, and we use NASA data for that.
Just to add on to that, they do move in real time, and we use TLE data from Celestrack, and it calculates their positions and in real time.
Excellent, thank you.
In order to make your project more impactful, have you considered adding more photorealistic renderings? You're probably familiar with the overview effect.
Yes, I think we have considered it. I think in this case, one of the reasons why the Earth image, for example, is kind of blurry is when we were developing, we just needed a faster iteration time. But I think we did consider using, for example, a NASA library like Whirlwind to get a more realistic image. But just for this first prototype, we used just a normal sphere.
Thank you.
Any other questions? Okay, thank you, Team Glass. Next team is Intergalactic Cowgirls. Great name. Are you guys ready to present?
Yes, we're ready.
Awesome. You have 4 minutes.
Wait, so the project name is Takeoff Washington.
You're accurate.
Please, you guys should mute it unless we're speaking. There's a little bit of echo.
Oh, is it? Okay. Our project name is Takeoff Washington, and then the challenge that we're addressing is space exploration in your backyard, and our team name is Intergalactic Cowgirls.
We're all University of Washington students. My name is Kaya, and I'm an industrial and systems engineering student.
My name is Maria, and I'm doing industrial and systems engineering.
My name's studying electrical.
And then my name is Stephanie. I'm double majoring in sociology and law, societies, and justice.
So for our solution, the problem that we are trying to solve with our project is there's no consolidated information about space organizations, events, and resources. There's also a need of better resources and education about how space explorations can benefit our local communities. and also the underrepresentation of female, Black, Asian, Hispanic, and Indigenous engineers and scientists in NASA. So with our project, we want to make sure K through 12 students and college students get more involved and have resources to get into space exploration.
So this is a screenshot of our prototype. We used our, specifically the Shiny package to create this. So you can see we have a map here, and each of the rockets indicates a location that's either business, academic, or recreational. And then you can see with our example here with SpaceX, we have a link to get more information. And then below the map, we have different tabs here. So the About tab is just going to explain why this resource is important. And then we also wanted to include local events, news, and highlight women from Washington.
So some of the next steps we wanted to take was to improve the UI. So maybe making it where whenever we click the rocket markers to have like a brief description of like how specifically that college or like observatory could help like underrepresented groups. And then we'd also like to compile more resources for Washington. We'd also like to, so right now we just have like static data that we all just researched and compiled. So we'd like to have like live data for like events and clubs for the tabs that we showed in the prototype. And we'd like to expand it to other states too, so it's not just Washington.
1 minute.
That was all. Did anyone have any questions?
Yeah, have you thought about how this would be integrated with various forms of social media so that as various events come up that you're publicizing it so that you can expand the sphere of influence of this information?
Yeah, I think in the map we could have more information about specific events and also link to maybe like a specific organization's social media, just so like the information can cross between those two platforms.
And question for me is, have you thought about how you'll be reaching out to underrepresented students?
Yeah, so I think if we add, we could reach out to different groups that also support underrepresented groups like in engineering and in science, and those groups could recommend this as a resource for students.
Thank you.
Quick question from me is, what's the inspiration for this?
So
I think that because all of us are minority students, like within to some extent like engineering, so that's why we kind of there's no inspiration for us to do it. Like there's no one to look up to, so we kind of just wanted to make something that is all, like we said, consolidated, so that we can just other people who are coming after us can just have someone to look up to, kind of thing.
Awesome, thank you.
Thank you so much, Intergalactic Cowgirls. That was great. Our next team is Internet on Mars. Are you guys ready to present?
Yep. Let me share my screen real quick.
You have 4 minutes. Thank you.
Okay. So we're the Internet on Mars team. We're a set of software engineers with a passion for teaching. We wanted to create a simulation to help solve and optimize the problem of getting internet or connection between Earth and Mars. So our application is essentially just a simulator of orbits. We use the Lagrange points on Earth to create basically a ping pong system, because the issue is with trying to just connect directly between Earth and Mars, the sun might be in the way, or the connection might take a really long time to get there because they're really far apart. So we need a communication network that can help solve that problem. Our initial foray into this is to, let me show the simulation. Our initial foray into this is more of an educational tool. We would like to create a tool for kids and just adults to understand this problem and get interested in it. Eventually, we'll add more math and more tools to actually create a useful simulation for engineers. Hopefully, it can grow up with kids who get interested in it and we can eventually have an internet connection on Mars. So the way it works, we can create some Lagrange points here. This is adding a satellite to the simulation, and then it calculates the ping between Earth and Mars through this satellite. So this is our initial foray into the problem. It will show you which satellite it is using here. So if I add another one, we can see eventually the points will orbit around so that it's going to use the Lagrange point 2. What we would like to add to this eventually, we would like to add protocols. We would like to add different hardware on the satellites like lasers or infrared, etc., to try to create an actual full-fledged simulation that allows engineers to create a system and optimize it for getting internet on Mars. So that's pretty much our presentation. I'm Paul. We've got Marek, who is a software engineer, Dustin, also a software engineer, and Wally, he has a background in mechanical engineering. He helped us with some of the, using some of the tools that already exist out there for solving this problem. So yeah, any questions?
Yeah, technical question. Have you thought of caching solutions? Like, for example, you don't need to have a live access to Wikipedia. You can perhaps copy all the Wikipedia into Mars orbit and have it be available locally and then update
Yes,
it
actually.
asynchronously.
Yeah, so when we were initially building this, we thought we might make a game. So you would have kind of a budget and different things you're trying to optimize. And part of one of the mechanics we thought about adding was turning these Lagrange point satellites into CDNs, essentially a content delivery network. So you can send, just like you just said, you can send all the information over, it'll store it, and then when it can see Mars, it'll send it back. This would allow us to have kind of a faster internet on Mars, but it wouldn't allow you to do things like, chatting with people and whatnot particularly quickly. But yes, that is definitely when we want to expand this, we want to add something like that to the simulation.
Thank you.
Any other questions?
Something to consider would be giving people access to in a more app-oriented way where they can get Facebook or they can get Instagram or TikTok, something like that, rather than focusing on general internet access.
Mm-hmm. Really, the internet on Mars is kind of a hook. The main thing is we want to try to create a communication network and a tool for optimizing that communication network, really. But yeah, that would definitely be, you could potentially have sort of a local internet on one of these Lagrange points where people on Mars are using, the Mars Facebook that communicates specifically with one of these Lagrange points, and then it's kind of like a bridge to Earth.
That's great clarification. Thanks.
We have time for one last question if there is one.
What's the current bandwidth between Mars and Earth? If you guys have been researching that, just curious.
So we have been researching it. We didn't spend a whole lot of time on it. We found there's a site for looking at the current deep space network connections. So we're not completely sure what the bandwidth is between Mars and Earth. But we know that there's a tool that NASA engineers use right now to simulate basically orbiting satellites and create a virtual network between them that we played around with a little bit. We didn't have time to integrate that data into here, but that's something we would like to eventually add, is to create a full virtual network that you can use a tool like Wireshark or something to actually analyze it and really get an idea of what's going to happen before you actually send satellites up that cost millions of dollars.
Yeah, this is James. It really varies. It depends on which individual orbiter you're hitting and what the position of Earth and Mars. So the ExoMars orbiter from Europe will be there soon too. This should help things out. All right, next presentation. Thank you for that, Paul. Next presentation is the Seattleites. Seattleites, are you guys ready to present?
Hi, yeah. Yes, can you hear? Okay, my Zoom is crashing for a bit. Okay,
yep,
so
you can hear you. Go ahead. You have 4 minutes.
Okay, cool. Okay, so yeah, we're the Seattleites. We're a group of undergraduate students. We tackled the Orbital Sky Challenge because I think what interested us the most was how essentially, a lot of people, including myself before I started this challenge, are not very informed on what the different artificial satellites that orbit our Earth actually do. We just kind of know that they're up there. So we created a web application using the several APIs to create this. Let me share my screen. All right. And so to start off, Luke's going to tell you guys a little bit about the SSC API that we use.
So basically we use the SSC API on NASA's website in order to get the latitude longitude coordinates for the various satellites so that we could place them in the proper place. That's what you see is the orange dots there. Each dot is a different satellite. Currently we have 30 given the data we have, because what we did is we got the latitude longitude coordinates from the SSC API, and we actually cross-referenced that with a JSON data file that Matt found that he'll speak to shortly after, that had more details on each satellite as well as the altitudes of the satellite so that we could place them properly. So Matt, do you want to talk about that CSV?
Yeah, so one of our struggles, I think, was actually finding some kind of data format that gave enough information that we actually wanted on all the satellites. So for example, the SSC API gave us the satellite names and their locations, but wouldn't actually really give any information on the satellites. So our solution for now was I found this database that is updated 3 times a year by a nonprofit organization. And we cross-referenced both of our data and tried to we linked whichever ones had common names so that we could use the data from Luke's API that he called from and the data from the CSV. So now that whenever you click on, just basically to give descriptions on each of the satellites. So, and then another API we use, which I think was talked about by another group previously, is the Whirlwind API. We basically took all that data we have to form these markers around the Earth that represent satellites. And when you click on the satellites, it gives the name and some information about the satellites. So for example, we still need to update some of the UI, but purpose, the type of orbit, period, launch date, launch site, and then a more information page. So if you just click on this link, this was a part of the database, the URL. So yeah, I could click on that and it would open up this URL. That is pretty much it.
Yeah, and then I guess just for future plans for this, obviously one, we want to optimize the UI, clean some things up and make it more, accessible for users. And then 2, we also wanted to add satellite trails because the SSC API actually gave us like 24-hour intervals of coordinates. So we wanted to use those in order to simulate the movement like over a 24-hour interval or even further, maybe over a month. You could specify the time frame. So that's plans for the future. But I think that's about it for our presentation. So thank you very much. And any questions?
Yes. What kind of impact do you believe this app will generate after it's completed?
Matt,
yeah, I can answer that. Our main goal was mainly just to give people accessibility to satellite information. So essentially, like someone like me, before we started this or came up with this idea, I always known there's satellites, artificial satellites that orbit the Earth, but I had no clue what any of them did, or I wouldn't even know really where to look. And with this, I think it's a fun, like interactive way to see the information, and it gives easy access to it. And especially if we optimize the data that we had and what we could display, it would be a really quick way of just seeing like all kinds of different satellites, what they do, links to web pages that have even more information about them. Yeah, so that was pretty much our main goal.
Matt and Luke, can you explain that a little bit further? Like, how could you optimize this view to make it easy for people who don't understand what these satellites do? What kind of things could you do?
So I think, okay, let me think of some things off the top of my head. let's see, we could add maybe filters by types of satellites. We could add maybe like some information tabs about what kinds of satellites there are.
Yeah, I think just general information, things like that. Like filters on the top, you can filter by what satellites are currently over the US, or filter by location, or filter by what the purpose of that satellite is. That gives a good general overview. And then maybe even adding more general information in addition to this interactive map, so that it can sort of be a one-stop shop for like the purpose of different satellites as a sort of holistic educational tool, rather than just pointing to other resources.
Okay, thank you guys so much. That was great.
Awesome.
Okay, I'm gonna go ahead and share my screen just to show the teams we have left here. So the ones that are italicized, we were able to do. We were able to do all these last ones here. So the next one we're going to try to do, if they're on the call, is Team Orbit. So is Team Orbit on the call? Okay, next one is going to be Fired Up. Is Fired Up on the call? Okay, next one is Agribusiness AI. Are you guys on the call? Next is Binary Search. Binary Search, are you guys on the call? Next is Trappist One. Trappist One, are you guys on the call? Okay, Fire Spotting team, are you guys ready to present now? Fire Spotting team, are you guys ready to present? That's too bad. They were on earlier. Check here. Elaine, is that you? Or no, Elizabeth, right? Fire Spotting team, are you guys ready to present? Alrighty, well, we had some great presentations. Thank you to everyone who participated. I'd now like to talk a little bit about the final submissions for your projects. So let me pull up that website here. This is the guide on the global organizing site for project submissions. You can find this. You could find this if you go to the resources, all resources page, and then it's the last link there, project submission guide. So this will tell you exactly what you need to do for tonight. You'll be logging into your team page. And then you'll be going into your project tab and then filling out this form. Now we've gotten some reports of people not being able to fill this out. I believe that's resolved now. If you do have any problems, let us know. We will be watching Slack tonight. If you have any issues submitting this, please let us know. But the deadline is tonight at 11:59 p.m. Our time zone. And then if you watch our website, spaceappsseattle.org, then we will announce our local judging. We will likely announce that by Monday the 12th. And we'll just put it on this main page here. We'll announce our results there. And then, yeah, thank you very much for participating. Does anyone have any final questions or comments?
Hey, it's Mike. I just want to say a big thank you to James and Jeff and Vladimir and Robert, our judges, but James, as a first-time Space Apps lead organizer, awesome job. Really appreciate the work that you've done over this summer and getting us to this point where we've got so many great teams and so many great projects to look at. This shows that COVID can't beat space apps, and you all are the power, the heart and soul of the space apps community. So great job to all of you, and Joseph, Nick, Carolyn.
Yeah, all the organizers did great.
Isabel, all of our organizers who were in the Slack, in the calls, helping the teams out and making this show possible. Thank you so much.
Thanks, Mike. I'd also like to invite everybody, if you look over my shoulder, there's a little poster back there. That's for the 2020 Mars Society Convention. It's in 2 weeks. I'm organizing that. It's got 4,000 attendees so far. We've got pretty much every NASA mission to Mars represented. For all the speakers from JPL will be at our conference. It's online, it's virtual, it's free this year. We also have a special guest I can't really talk about, but it'll be worth seeing. So please come to our event. You can find out more information, marssociety.org. So thanks a lot, everybody. And we'll see you next year.
Thanks.
Thank you.
Thank you.
All right,
Thank
everyone,
you.
remember, don't forget to take some food home. There's food in the kitchen. Bag it up, take it home. Oh wait, never mind.
Next year.
Next year, definitely next year food.
We hope to be back in Seattle next year.